And what we saw was that the bacteria more or less would abandon production of all these other small peptides and then instead increase production of andromid.
My name is Månsson. I've been working as a marine natural product chemist, and I'm so lucky that for the next 3 years I will be working on discovering new exciting molecules from marine bacteria. Because the oceans are still so unexplored, the chances of you actually finding something new is very big. And sometimes you get the feeling that you just need the key to unlock a whole new suite of compounds that you've never seen before.
This is the foundation of my new postdoc project just starting up. We call it ecology-driven drug discovery. And the whole question is, of course, can we try to access some of these exciting new chemical compounds that the genes promise?
In my new postdoc project, we're working on the hypothesis that if we use the ecology of the organisms, we might be able to unlock some of the compounds that the bacteria don't produce in the lab but might only produce in nature. And will that suddenly unlock a whole new area of compounds that we've never seen before? That's very exciting, having that feeling, being on the edge of a great new discovery.
I'm very intrigued with the whole association between these heterotrophic bacteria and their surfaces. So together with Bill Gerwick, we're going to see if there could be any induction of production of these compounds when we grow them together with cyanobacteria.
This is a field where people collaborate and you can learn from the best. For me, I get a chance to come to work at the Scripps Institution of Oceanography and work with the best people in the field.
Being the inspiration, giving rise to now 3 drugs that are used in treatment of cancer and 1 in viral infections. And then a couple of other anti-cancer agents, these complex structures perhaps.
They managed to integrate state-of-the-art genomic analyses or state-of-the-art molecular tools or great new ways to do their microbiology, and they integrate new instrumentation for their chemical analyses. And in that sense, it's a very interesting field to work with because everybody's on their toes.
Interestingly enough, in another group within the same species, we saw a different pattern of bioactivity.
You're expected to challenge the field. You're expected to come in with new ideas that come from different areas. So in that sense, it's a very open-minded field that people want to have new ideas and they want to challenge the old ideas of how to do things. So that's extremely inspiring.
These compounds might actually be produced in nature, and maybe we can use some of these natural clues to access new compounds.
Nature is a much better chemist than we are. It's much more inventive and can find new structural scaffolds that we don't even have the imagination to come up with. There's still a lot of things out there. You can pick up an organism that nobody has ever looked at before. You really have a chance to see. I've actually been the one to see this for the first time.